Picture a field of crops, right? Just a normal rural farm. Now, right in the middle of it, I want you to drop a glowing, high-tech server rack routing global data and an industrial laser welding shop.
It is such a wild mental image.
It really is. Today, we are looking at a system that basically turns a rural farm into its own power plant, its own manufacturing facility, and, a sovereign AI data center.
Yeah, it completely upends what you expect a farm to look like.
Exactly. So we are diving into a stack of technical documents today from an ecosystem called Ecoladang microfarms. Specifically, we're exploring this pillar they call infrastructure and support services.
Right, which is really the core of the whole operation.
Yeah. And our mission for this deep dive is to understand how this physical and digital architecture forms the backbone of absolute operational resilience. It's all about ensuring maximum uptime and completely redefining agricultural infrastructure for you.
The visual tension you just described at the start, that's fundamental to understanding this entire model. Like, if you look at the visual I've got running behind me today, it's this split screen.
Oh, yeah, the liquid-cooled servers.
Exactly. On one side, you have that high-density liquid-cooled AI server rack. And on the other side, there's a heavily engineered modular farm just blanketed in solar arrays and heavy machinery.
It looks more like a sci-fi set than a farm.
It really does.
Yeah.
But we're examining an infrastructure that's engineered not just to grow food, but to completely isolate itself from external supply chain vulnerabilities. I mean, it's about securing uptime at literally all costs.
Okay, let's unpack this. Because if you are deploying heavy modular units like these private compact data space containers, the PCDS units they call them.
Right, the PCDS.
Yeah, or an on-site biomass energy plant, you can't just drop those onto loose topsoil, right? Like, you need serious long-term stability.
Absolutely. The civil and structural engineering is step one here.
The sources detail these comprehensive site surveys, heavy earthworks, and foundation prep before a single seed is even planted. I keep thinking about this like, building a self-sustaining Mars colony right here on Earth.
That's actually a really good analogy.
Right, because first you have to establish the physical foundation, the life support, and an unbreakable microgrid. You can't just plug a massive AI farm into a standard wall outlet.
No, you definitely can't. The load-bearing requirements are closer to a heavy industrial park than a traditional farm.
Yeah.
You're dealing with, severe soil compression issues when you place high-density computing containers and massive biomass diggers in a rural landscape.
Because the ground naturally shifts.
Right, exactly.
Yeah.
The earthworks ensure that seasonal ground shifting or, say, heavy rainfall doesn't compromise the structural integrity of those really high-value assets. I mean, think about it. If a data center container shifts even a few degrees in the mud...
Oh, you'd snap the connections.
Exactly. You risk severing fiber optic lines or completely disrupting internal liquid cooling loops. It'd be catastrophic.
Which, that brings us to the energy equation. If you are entirely off-grid, or at least operating as an independent microgrid, how in the world are you balancing the massive, spiky power draw of an industrial welding shop with the delicate, constant power needs of a data center?
It's a huge challenge.
Because solar arrays are great, but they're intermittent. Like, what happens at 2 in the morning when a storm rolls in?
That is where the integrated biomass energy plant steps in. It becomes the anchor of their whole integrated energy management system. And they aren't just, throwing scrap wood into a fire.
Right. The sources said it's a gasification process.
Yeah. They take agricultural waste and heat it in a highly controlled, oxygen-deprived environment.
So it doesn't just burn up and make smoke.
Exactly. Instead of smoke, it creates syngas, which is this mixture of carbon monoxide and hydrogen. And then that gas is combusted to drive a turbine.
Oh, wow. So they're manufacturing their own generator fuel on site.
Yeah. It provides this steady, controllable baseload of power that solar simply cannot offer on its own. It's a closed-loop thermodynamic system that acts as the backbone whenever solar yields drop off.
I see the logic there, but combining industrial fabrication, data servers, and agriculture on a single microgrid, I mean, that introduces massive load balancing issues, right?
Oh, definitely.
This is where the sources highlight their use of advanced power transfer switches, the APTs. And looking at how Ecoladang configures these, they aren't just, standard industrial trip switches you'd buy off the shelf.
No, they're highly specialized. They're calibrated specifically to protect very delicate hydroponic and environmental thresholds.
Right, because if the power dips, the plants are in trouble.
Well, we have to look at the consequences of a power failure in this specific ecosystem. In traditional agriculture, if the grid goes down, maybe your irrigation pump stops for an hour, but the soil retains moisture.
Yeah, the dirt acts like a sponge. It buys you
Mhm.
time.
Exactly. But in Ecoladang's controlled environment agriculture modules, the CEA modules, where they grow these high-yield, delicate crops hydroponically or aeroponically, the plants just do not have a buffer.
Right, because their roots are literally suspended in the air or just sitting in shallow nutrient films. If the pump stops, they begin desiccating immediately.
Precisely. They dry out incredibly fast. Furthermore, even a 10-minute power drop means the humidity controls fail.
Oh, and then you lose the atmosphere.
Right, the atmospheric equilibrium is lost, condensation builds up on the walls, and that can trigger catastrophic fungal rot in just a few hours.
Wow, just from a 10-minute outage.
Yeah. So the APT switches ensure continuous, seamless power by instantaneously shifting the load. They jump between the solar batteries, the biomass syngas generator, and the local grid without a single millisecond of interruption.
So it's totally seamless.
Completely. Yeah. It safeguards the environmental controls and, just as importantly, prevents the PCDS data servers from hard crashing.
Okay, so you've successfully secured your foundation and your unbreakable power supply. But you have just created an entirely new bottleneck here.
How so?
Well, you now have highly complex, proprietary industrial-grade equipment operating out in a rural area. When a specialized loader or a biomass turbine breaks, a traditional supply chain isn't coming to save you quickly.
That's very true.
Waiting 3 weeks for an external vendor to ship a proprietary part out to the countryside could easily ruin an entire harvest cycle.
And that vulnerability is exactly what their self-sufficiency strategy is engineered to eliminate. Rather than relying on slow external logistics, they internalize the maintenance entirely.
But the solution laid out in the documents is intense, like they build a multidisciplinary industrial manufacturing plant directly on the farm.
Yeah, they do.
If you're looking at this from an investment or a capex standpoint, isn't it massive overkill to build heavy industry garages right next to a crop field?
Well, it looks like an exorbitant capital expenditure up front. Absolutely. But you have to run the financial models on compounding downtime.
Ah, because the downtime costs more than the garage?
Exactly. By building out 4 distinct technical workshops on site, they mitigate the risk of catastrophic operational pauses. They effectively transform from a consumer of agricultural equipment parts to a localized manufacturer of those parts.
Okay, let's break down the mechanics of these 4 workshops, because the capabilities listed here are staggering. The first one is the general maintenance workshop.
Right, that's your standard daily operations hub.
Yeah, fixing PVC plumbing, repairing small water pumps, that kind of daily hardware upkeep. But the escalation happens in the heavy industry workshop.
Oh, yeah. This unit bypasses the traditional dealership model entirely. Traditionally, if an excavator, a bulldozer, or a specialized heavy loader suffers, say, a hydraulic failure out in field,
You have to load it onto a flatbed truck, right?
exactly, you haul it miles away to an authorized service center and wait. But Ecoladang's heavy industry bay is already equipped with the hoists, the pneumatic tools, and the diagnostic hardware to service those high-value heavy agro vehicles internally.
Which obviously saves the transportation cost and cuts the repair time from weeks to just hours.
Right.
But the fabrication workshop, that's where this ecosystem acts like a rapid prototyping lab. They are working with mild steel and aluminum.
Yes, and that's crucial.
If a structural bracket snaps on a proprietary harvesting machine, they don't even call the manufacturer. They fire up CAD software, design a new housing unit, and fabricate the structural component right there.
And, that level of independence requires serious metallurgical capabilities, which is housed in the 4th unit, the welding workshop.
Right, the welding bay.
The technical documentation here is fascinating because it details very specific applications. They utilize TIG tungsten inert gas and laser welders alongside more standard MIG and stick welding.
Which is an important distinction, I think, for anyone wondering why a farm needs aerospace-grade laser welding tools.
It sounds like overkill again, right?
It does, but when you are running a controlled environment agriculture module, a microfracture in the aluminum chassis isn't just a draft.
No, it destroys the hermetic seal.
Exactly. You lose the atmospheric equilibrium required for the crops, and airborne pathogens can just drift right in. You can't just patch that with standard stick welding. You need the precision of TIG, or laser welders, to create flawless, airtight seals directly on the farm.
Yeah, the thermal control of TIG welding allows for those precision hermetic seals on thin metals without warping the structural integrity of the CEA modules.
Because if you warp the frame, the whole module is compromised.
Exactly. Conversely, when a heavy loader cracks a huge load-bearing frame, they switch to the MIG metal inert gas or stick welders, which are designed for deep penetration on thick, heavy metals. And they also maintain specialized gauging tools for precisely cutting, shaping, and removing material during those heavy fabrications.
Okay, so we have an incredibly robust physical layer. We have fortified earthworks, continuous microgrid power balancing, and the heavy industrial tools to fabricate or repair literally anything on site.
The whole physical package.
Right. But fixing a tractor chassis or sealing a hydroponic tube is purely mechanical. Orchestrating the continuous optimization of biomass yields, solar battery storage, and climate control, all at the same time, that requires a brain.
And this transition from physical infrastructure to the digital foundation is where the ecosystem truly scales. The brain you mentioned is the Private Compact Data Space, or PCDS.
Right.
This is a hardened, localized AI data center sitting right on the property.
And my immediate question reading this was, why build a physical server container on a farm when AWS or Microsoft Azure exist? Like, why not just push your farm's sensor data to the cloud like every other modern ag tech startup does?
It comes down to three things: latency, security, and absolute sovereignty.
Sovereignty being the key word there.
Exactly. The PCDS operates as a sovereign AI environment. The operator's metrics, their financial data, and their proprietary AI optimization algorithms are never exposed to external cloud providers. They own their data completely.
That's a huge shift from the current tech model.
It really is.
Yeah.
Furthermore, if you are relying on an external cloud to manage the millisecond timing of your APT power switches or the thermal loops in your biomass plant.
Oh, I see. A rural internet outage becomes a catastrophic physical failure.
Precisely. If someone cuts a fiber line 3 towns over, your farm goes down. By keeping the compute local, the microfarm functions perfectly, even if the outside world goes completely dark.
Which explains the massive redundancy in their network management setup. They aren't taking any chances with connectivity. The sources show they utilize Starlink Business for low-latency satellite uplink. They layer that with 4G or 5G shared services, and then they blanket the whole microfarm in a local Wi-Fi mesh network.
Just to keep everything talking internally.
Right, to keep all the IoT sensors and micro units talking directly to the PCDS.
And that redundant network stack ensures that the AI can instantly analyze performance across the entire facility. It identifies bottlenecks in crop yields or energy consumption locally, while selectively pushing encrypted summary data out to broader networks only when necessary.
But, even the most advanced localized AI can't physically run a TIG welder, right?
Right.
Or perform a pneumatic repair on an excavator.
Not yet, anyway.
Right. You still need skilled humans. And this introduces a massive socioeconomic hurdle. How do you convince highly specialized laser welders, hydraulic mechanics, and network engineers to move out and work on a rural microfarm?
That is the brilliance of the Ecoladang model. They don't try to recruit them, they manufacture them.
I love that phrasing.
It brings us right to their human capital development. Those 4 massive technical workshops we just discussed, they aren't just for internal repair. They simultaneously serve as the vocational training center.
Here's where it gets really interesting to me. It's essentially a teaching hospital, but for advanced agricultural and industrial technology.
But that's exactly how it functions.
They offer these structured apprenticeship programs interwoven directly into the daily operations of the farm.
By embedding the training directly into the operational infrastructure, the apprentices are learning on live critical systems. They aren't just reading textbooks.
Right. The stakes are real.
Exactly. They offer highly specific vocational tracks, too.
Yeah.
Advanced welding and fabrication,
Right.
agricultural equipment maintenance, renewable energy systems, and low-voltage industrial electrification.
So the renewable energy apprentices are out there actively balancing the load between the solar arrays and the biomass syngas turbines.
Yes.
And the electrification apprentices are actually configuring those critical APT switches we talked about. They are generating a continuous localized pipeline of skilled personnel.
And the broader socioeconomic impact of that is profound, if you think about it. They aren't just securing human capital for their own operations, they are upskilling the entire surrounding community.
Giving rural kids access to industrial tech skills.
Right. It ensures that as the ecosystem expands, there's a ready-made workforce capable of operating and maintaining these highly complex microfarms. It's literally an infrastructure that builds its own operators.
Wow. Okay, so We have covered a massive amount of physical and digital engineering here. We have heavy earthworks, gasification plants, laser welding bays, sovereign data centers, and an apprenticeship pipeline.
That's a lot to take in.
It really is. But let's look at this from a business perspective for a second. We have to ask the ultimate question. How does this massive CapEx actually translate into profit and survival?
The bottom line.
Right, because you are asking an operator to manage an energy plant, a data center, a manufacturing hub, and a crop yield simultaneously.
Well, the overarching strategy unifying all this infrastructure is what they call strategic risk mitigation.
Okay, how does that work in practice?
In traditional agriculture, your financial survival is tied to the yield and the market price of maybe one or two commodities.
Yeah, like soybeans or corn.
Exactly. If a blight hits or the market for soybeans crashes, you just go bankrupt. But the Ecoladang infrastructure is designed for extreme diversification. The system generates profit from 7 distinct synergistic sources.
7 independent revenue streams, meaning if the agricultural market takes a dive, the farm's other utilities absorb the shock.
Exactly.
Let's drill down into these because the economic model is really fascinating. You have the energy generation. If they produce surplus power via solar or syngas, can they push that back to the local grid for profit?
Depending on local grid regulations, yes, energy exportation is a very viable revenue stream. But honestly, the more compelling technological revenue stream is data processing.
The sovereign compute. I really want to explore this because the idea of a farm acting as a global data server to generate extra income is just wild.
It sounds like science fiction, yeah.
Like, who is buying compute power from a rural agricultural facility?
You have to look at the broader trends in decentralized computing for this to make sense. Not every client wants their sensitive data processed in massive centralized server farms owned by, huge tech monopolies.
Right, people are getting wary of the big tech clouds.
Exactly. There is a massive growing market for decentralized edge computing networks. Clients running cryptographic hashing, complex 3D rendering, or localized AI model training, they will purchase distributed compute power.
And because the farm has the PCDS?
Right. Because the PCDS is a hardened, sovereign environment with its own robust power generation, it can proactively lease out its unused processing cycles to global clients. It generates passive income while simultaneously running the farm.
That is incredible. The microfarm's brain is essentially moonlighting as a commercial server farm.
That's a great way to put it.
So alongside the tech and energy revenue, they're obviously producing crops. But the sources note they focus on high-value niche products.
Yes. Specifically things like fresh mycelium mushroom farming and processed insect meal.
The choice of crops is highly intentional, isn't it?
Very. Insect meal is a rapidly growing, incredibly efficient source of protein for livestock and aquaculture. And mycelium offers rapid harvest cycles and incredibly high market value. However,
There's a catch.
there's always a catch. Growing these biological products is only half the economic battle.
Right, which is exactly the problem with rural farming. You can cultivate the highest quality fresh mycelium in the world, but mushrooms have incredibly high respiration rates.
They go bad so fast.
Yeah, if you don't cool them immediately, they degrade in hours. If they rot before reaching the buyer, your high-yield crop is financially worthless.
Which brings us to the logistics layer of their infrastructure. The ecosystem doesn't stop at just cultivation. It actually includes built-in services for cold chain logistics, packaging, and market distribution.
Using the microgrid again.
Exactly. They utilize the microgrid's steady power to run industrial blast chillers and localized cold storage right there on the farm.
So they are preserving the thermodynamic integrity of the crop from the exact moment it is harvested.
Yes. It ensures that highly perishable products survive the transit to regional or even international buyers. It basically solves the primary market access challenge for rural producers.
Okay, but you raised a crucial point earlier about the sheer complexity of managing all this. How does someone balance blast chillers, Syngas turbines, laser welding schedules, and edge compute server leases without just being totally overwhelmed?
They have a lot of spinning plates.
Right. The cognitive load of running a 7-stream ecosystem would break any traditional farm manager. I would lose my mind trying to manage a server farm and a blast chiller at the same time.
Oh, absolutely. Anyone would. And this is where the digital foundation loops back in to save the day. The sources highlight that Ecoladang packages basically 4 decades of IT and operational expertise into AI-driven standard operating procedures, or SOPs.
So the AI is running the show.
Mostly, yes. The PCDS isn't just monitoring the temperature sensors, it is acting as a hyper-advanced enterprise resource planning system.
What?
The localized AI dictates repeatable, highly optimized SOPs.
Giving instructions to the humans.
Right. It tells the operator exactly when to load more biomass based on upcoming cloud cover that it knows will drop solar yields. It schedules preventative maintenance in the heavy industry bay because it's reading pneumatic wear and tear sensors on the excavators.
Oh, wow. It takes all the guesswork out of the synergistic balance. The operator's just executing a proven operating system.
Exactly.
They aren't out there trying to figure out the thermodynamics of Singas on the fly. The infrastructure's brain is guiding the daily workflow to minimize operational risk and maximize those 7 revenue streams.
It creates a perfectly closed loop economic engine. Think about it. The power supports the agricultural waste feeds the power plant, the workshops fix the physical tools, the AI optimizes the whole system, and the apprentices ensure there are always skilled hands to run it.
It is a phenomenal masterclass in resilience engineering. So, to synthesize what we've explored today for everyone listening, this ecosystem completely dismantles the traditional vulnerabilities of rural agriculture.
Piece by piece.
Right. They secure the physical layer with heavy simul earthworks and APT switches that seamlessly transition power between solar and biomass gasification, just to protect those fragile hydroponic ecosystems.
Yeah.
And then they insulate themselves from supply chain shocks by building industrial fabrication and precision welding bays right on the farm, simultaneously using those same workshops to train the next generation of technical experts.
It's so efficient.
And finally, they orchestrate this massive complexity through a sovereign, localized AI data center that not only runs the farm's SOPs, but actively generates revenue through decentralized edge computing.
They have essentially engineered a system that empowers local communities by turning them into self-sufficient, technologically advanced economic hubs.
We started this deep dive exploring the traditional vulnerable image of farming, the reliance on weather, the slow logistics, the heavy reliance on external supply chains.
And I want to leave you with a final thought to ponder as you look at the systems around you today. Historically, society has viewed rural agricultural areas as peripheral, right?
Yeah, just places that grow stuff.
Exactly. Places that simply extract raw materials and ship them off to high-tech cities where the actual innovation supposedly happens. But if an infrastructure model like this can turn a rural farm into its own localized power grid, its own sovereign data center, and an advanced industrial fabrication hub,
It changes everything.
it really does. Are we looking at a rapidly approaching future where the most resilient, technologically sovereign, and economically independent communities aren't clustered in urban tech hubs like Silicon Valley, but are actually sitting quietly right in the middle of an agricultural field?
That completely upends how we think about the geography of technology and resilience. The infrastructure of the future is going to look vastly different than we expect. Thank you so much for joining us on this deep dive. Keep questioning the mechanics of the systems you rely on, and we will catch you next time.